Today we're going to be talking about modernization, taming the legacy, and keeping the new house clean. So my name is Barry Postma, I'm the tech principal at Thoughtworks in London. And let's dive straight in. So one of the things that we often see with modernization projects is that the gravitational pull of legacy is really strong. And so I often hear things like, let's just build it in the old system because it's going to be quicker that way. Or, we can't do this yet because it's still in the legacy system, so we'll have to build an integration. So then when you do start off on a modernization journey, how do you keep the new software that you're building clean? And when we start off, we have some tendencies. We have natural instincts. So we tend to start with assembling the best team of developers that we have, the best technology that we can find. And we try to care quite a lot because our customers use the software already, we know exactly what they're expecting, and so we care a great deal about what they're going to need. And we make decisions. We make bold decisions because we're building the future and it's going to be different this time. We really promise it's going to be different. But what if we did the opposite of these things? What if we started off not with assembling the best team, but with designing how we want it to work? And instead of caring a great deal, what if we would care a great deal about not caring? And instead of making bold decisions, we made the decision to defer decisions to later on. Now, these are in terms of ways of working and how we structure our programs. But in the architectural space, we tend to list functionality. We know the legacy system inside out, and so it's very easy to make a list of all the things that we're going to need. And we often take the simple route into legacy as well. There's going to be a moment where we're going to have to integrate. There's no escape. But doing that the easy way, because it's complex enough and we don't want to deal with it, is a tendency we have. And lastly, we tend to centralize and reuse, because we're going to build all this new stuff, and surely at some point this is going to come in useful, right? Well, again, what if we did the opposite? So what if we were to define a purpose of our architectural layers before we start listing out all of the functionality that we need? And what if we plan our routes into legacy very carefully, rather than just integrating directly because it's complex enough? And what if we decentralize instead of centralize, where maybe reuse is optional? Well, if we do those opposite things, and that's exactly what we did, and we take all of those tendencies away, we might end up with 6 principles that can actually help us be a little bit more successful in our modernization journeys than a lot of programs are. So first I want to share what I've come across over the years. There's an interesting pattern that I've noticed when clients tend to modernize their programs. As consultants, we're often brought in after the fact, unfortunately. So something of this modernization just wasn't delivering upon its promise. And then when we look at what's happening, there is a remarkably similar architecture that starts to emerge with all of these clients. So I want to take you through 3 exhibits of completely different clients. But take a look at this exhibit number 1. So this is a client who had software in the legal industry, and it allows you to search millions of legal documents. Now what they had on the left is we can see they have a mainframe with a lot of programs running on them. In the middle they have various services that they call the transaction administration services. And the front end are a set of applications that their customers would use to interact with all of their data. Now the software used here is a DB2 database, Java, CORBA protocols, and the front end was written in JSP that would communicate over SOAP, all too familiar. So they started a 7-year modernization journey when we came in, and this is what they ended up with. So the picture looks very similar. They had swapped out their DB2 and their mainframe for a database called MarkLogic. It's not very popular, but it's an XML-based database. They had swapped out their transaction administration services for what they're now called shared services. That were still written in Java, but they would use REST API calls instead of CORBA. And the front end was consolidated. So they built it using ASP.NET MVC and AJAX this time. But because the front ends were consolidated into one and a lot of development work happened, they built a custom framework on top of that to steer everyone in the right direction, or that was the idea. So then the teams that were working on this software also remained the same. So they were functionally decomposed. And any change that we wanted to bring about in the front end required a minimum of 3 teams to be involved and coordination across all of them. And obviously, the teams in the middle had the toughest job because all of the work would funnel through them, and whoever came first was the one that was going to be releasing the earliest. So what was the result? Well, their modernization journey, unfortunately, did not deliver upon the performance improvement that they wanted to achieve. And the speed of development, bringing new features and innovation to customers, also went down compared to legacy because there was a complex piece of software to work with, the front-end framework, and they couldn't afford integrating with legacy at times. So changes were needed in legacy as well as in the new architecture. So another example, exhibit number 2, completely different industry, software for the insurance market. So the way this software works is it allows you to build very complex forms that can ask questions. For example, what make and model your car is, what your driveway looks like, how your property is secured. You would enter all that information and it would give you a premium for your car insurance. So in order to build those complex forms, they had a tool called a Screen Builder, which was a Windows desktop application that would generate DLL files with the models inside them. And they had a policy administration system that would read those files and generate those screens on the fly. That Screen Builder tool would also procure the tables and the structure in the database, so that when the data was entered, it could be saved in those tables and columns. So the modernization journey began, and they switched to web technologies. So they replaced the Screen Builder with a forms designer, this time using Angular. They replaced the DLL file with a JSON schema, and they swapped out Microsoft SQL Server for MongoDB. So they went from structured to a little bit more unstructured data. And the front end now became a two-tiered microservices architecture that was communicating with backend services over REST rather than being a fat Windows desktop application. But they took a shortcut, and that's the big red arrow in the middle. So in order to bring any new insurance products to market, they still had to create the models in the old system because the new system relied on the DLL files of the old one. And this was a critical dependency that got introduced. So again, what was the result? Well, the client wanted to take insurance products to market quicker, and unfortunately, it actually took longer to take insurance products to market because any change in the new system required a change in the old system. And also, changing a form in the forms designer required changes to the microservices architecture in the new architecture. So exhibit number 3, and I think you're getting the sense of where I'm going with this. This is from a retail banking client. So again, a very different industry. As you might expect, they had a mainframe with COBOL programs and Java programs and a DB2 database, a set of databases. And they had an enterprise service bus. It was their multi-channel architecture, as they called it. And that enterprise service bus would connect thousands of programs on the mainframe and other services in the bank together in order to serve customers over different channels. So for example, mobile apps, web browsers, or even ATM cash machines. So configuring the entire enterprise just in one enterprise service bus was actually an awful lot of work and was a bottleneck for innovation. So when they started to modernize, the mainframe remained the same. The programs on the mainframe remained the same, and they swapped out this enterprise service bus, their multi-channel architecture, for components written in Java. They had loads of jars that ran on one Java virtual machine that could not scale horizontally. And all of this complex logic for the channel, if you're a mobile app, do this. If you're a web browser, do that, now became its own Java module, which exploded in lines of code and complexity. So what was the result? Well, reducing cost by offloading from the mainframe certainly did not happen, unfortunately. In fact, the cost actually increased because the integrations between the new system and the old system got them to a point where they realized the old system was probably never going to be turned off, at the point where they had realized they needed to modernize their modernization. This third example is a case study. But what we often see across all of these examples, and I think you're seeing where I'm going, is that it's quite clear which forces are at play. One is that modernization often starts within IT. It's an IT project. And the people who are working on it are often developers, and they see modernization as a problem to solve. So what tool to better use than newer technology instead of the old technology? And that's what we just saw. Old technology gets replaced by new technology. We also often see that communication structures remain the same. So people are still in the same teams, people still have their same friends from across the business, and people still sit behind the same ticketing systems. And people often design what tomorrow should look like by looking at what there is today. So the conclusion is that it's very easy when you start to modernize to end up in the position that you are actually trying to escape from. And that is the gravitational pull that I keep referring to. So the 6 principles may help with taming some of this gravitational pull. So what can we do differently? So for this retail banking client, we picked one specific area of their software that we wanted to modernize. They asked us to help them be their transformation partner, become cloud native, become digital, and all the modern buzzwords that you would expect. So we came in and we actually looked at their software estate not through a technical lens, but through a lens of who is doing the work and when are they doing the work. And they needed to accelerate. Especially during the pandemic, the use of mobile channels was exploding and they needed to increase their innovation. But they were bottlenecked by this multi-channel architecture they had in the middle. That had grown very complex. So we picked a thin slice. We took a thin slice approach, and that was going to be what we called bill payments. Now, this bank offered customers to pay their utility bills from their mobile banking app. And so any company that was signed up was able to have their logo listed. You would select the company that you wanted to pay a bill for, enter your customer number, and your bills would be listed on screen. You would select the bill that you wanted to pay, and you would select the payment method, your bank account or your credit card. You would hit submit, and the money would be paid between bank accounts, and the company would be informed that your bill had been paid. Now, this is a relatively simple journey, but it did imply that we had to make changes to the mobile app. We had to make changes to the underlying back-end systems, and we didn't know how many there were going to be. And we knew that we're going to have to somehow affect the mainframe because that's where the real money was being moved between bank accounts. So let's take a look at those 6 principles through the lens of 6 challenges that we faced on the journey of building out this relatively simple bill payments journey. We took the opposite approach from all of our tendencies. And the first one was to design how we wanted to work. So we started off with understanding the motivations of our clients. And their motivation at that point was to gain confidence that modernization would actually be feasible. So we needed to make sure that we had a small scope that allowed us to tell our stakeholders that we were going to be successful and demonstrate that at the same time. So we had a choice. And the choice was, are we going to be a new team who is coordinating? We did not know how many other teams across the bank to make changes in different parts of their software. Or were we going to be a small, nimble team that could move quickly? And there were some challenges. For example, we were foreseeing that we were going to be dependent on a lot of knowledge that was outside of our team, that was scattered throughout the organization. And also, there was a real risk that we would think as a team we were done, only to find out someone else on the other side of the building would say, yeah, but you can't take that to production just yet. And this actually happened. So we had to evaluate how we were going to go forward, and we knew that the only way we could move forward was to take a radical approach. And so we assembled a team that was going to work different from the teams that they had had before. Now, for anyone who's not familiar with Conway's law states that any organization is very likely to produce a system, in this case, that is a copy of how that organization is structured and how the communication in that organization is structured. And that's what the picture here is trying to show. And we did not want this to happen. So the solution was to assemble a cross-functional team. And this picture here is actually displaying what our team looked like. So we focused on a couple of things. One was we wanted really short feedback loops. We wanted people on the team to have direct conversations with one another, where normally they might have had to set up a meeting with someone else. We wanted to have the skills and knowledge on board to build out this core journey without having to depend on knowledge across the organization. And we wanted to find the right candidates. Now, those were not necessarily the rockstar developers that knew legacy systems inside out, or the best coders. In fact, they were people who were new to the business, or they were people who knew what wasn't working well and had an open mind to trying something different this time. So for example, once we assembled this cross-functional team, our quality assurance engineers and our developers, whilst working on a story, were able to have direct conversations and do exploratory testing before they'd even completed their work. And project managers and business analysts were able to communicate almost on a daily basis what the status of our dependencies were and if we had to change our timelines. Now, none of these things would have been possible had we had to coordinate across various teams in the business. So the second principle that we followed was we cared a great deal about not caring, and we were ruthlessly ignoring what we just didn't need. Our objective was to limit the scope to bill payments, but bill payments was a big feature, and you could do a lot with it. So for this principle, we said, actually, we need to limit even what we're going to do within bill payments. Because what we're trying to prove is that confidence to our stakeholders, and we need to get working software in production as soon as possible. So again, we were faced with lots of choices. Were we going to build a minimum viable product, an MVP that everyone always talks about? Or are we going to put stuff in production once other things go into production in the organization? And we evaluated this and realized with our stakeholders that an MVP for them meant almost the same as what existed today. So at our time scale, that meant we could maybe go live in 3 years, and we hadn't proven anything in the meantime. So we realized that maybe an MVP was not the right approach because the product was already viable. It was already proven. We had to reframe the problem. So we reframed the problem as a shortest path to value. And value here, again, was confidence to our stakeholders and proving that we could carve off a tiny bit of functionality from the legacy software. The way we went about that was we challenged the team. So we looked at bill payments. We asked the team to look at what would it take to build this. And even at that point when they built it, we asked them, what can you take away? Or what can you defer to later? And so we ended up with a really small thing, which was definitely not ready to be used by customers. But it was okay, because a few iterations later, we would be ready to go to customers. So our delivery and our release were not necessarily the same thing anymore. We challenged the team, and we also challenged our stakeholders. The customer expectations had changed since the last time they designed this bill payments journey. So how did we know that it was actually still fulfilling customer needs? There was actually no harm in starting really simple, listening to customer feedback, and then building it out. And it's very likely you end up in a different place from the place that you were trying to modernize. And the last thing we did was we looked at data. So I'll give you one example. There was a functionality to scan a QR code on your bill. It would pre-fill all the fields, and you only had to select the bank account you wanted to pay from. Now that seems very useful and very simple to make. But out of thousands of companies who allowed you to pay their bill, there was only one that used it. And from that one company, only a small percentage of their customers would actually use the functionality. So this was definitely not a must-have. The only way we knew this was by looking at data. For the third principle, we decided to defer decisions. And our mantra was, is this the last responsible moment or not? So we trimmed our scope. We had a viable path to production to deliver a very simple piece of functionality. But dependencies and integrations were still looming on the horizon. We knew they were coming, but we would only uncover them, as you do with legacy modernization, the moment you need certain functionality. So our objective was we had to de-risk this approach, and we had to de-risk our timelines, because we could be doing this forever. So there were multiple ways for us to approach this problem, and we had to ask ourselves the question constantly, can we wait and decide this later? Can the team find a technical solution around this? Or do we actually have to make a decision right now? So with so many APIs to build and integrations, APIs to call and integrations to build, if other teams would not be ready, our team would be blocked. So rushing decisions might not have been the right thing to do. Now, as you might hear from a consultant, the real answer here was it depends on what you do next. And we boiled it down to two. One of the things we did was we made no decisions on any integrations that we didn't need yet. So we asked the team to hard code certain features so that when the integration was available, they would just have to swap it out for the response of an API. For example, the list of bank accounts. The other thing we did was remove premature optimizations. Now that could be optimizations in the user journey, but it also meant concepts like caching. There was no data to suggest that we needed caching, that we were slow. So why not defer those things in our backlog? And we refined our backlog constantly. We constantly looked at which functionality can we hard code or can we come back to before we actually need to ship this to customers in a way that it's working for them. So then moving into the 3 architectural principles. It's not only non-tech, I promise you that. So the 4th principle was to think about purpose rather than functionality. So we had designed the team to own the tech stack and have all the knowledge on board, but we also wanted them to have a low cognitive load of all of the things they had to care about and that were under their control. So did we want to design a system where all of those functionalities that we listed ended up as being a set of architectural components? Or did we want to keep things simpler and talk about the purpose of architectural components? Now, one example would be we found an API, and in fact there were 3 of them, that could list bank accounts. But that was the only thing it could do. So that was a very functional piece in the existing architecture. But we also found APIs that could list bank accounts, would give us the name of the customer, would give us payment limits, and would show which bank cards were associated with the bank accounts. Now, the purpose of such an API is to give you information about bank accounts, and so it was far more well-rounded. Now, this is a bit subtle, but what we did was we started to draw up the current architecture. And that was a challenge. As you might remember from Conway's law, if there are a lot of parts in the organization that are disjointed, there's probably a disjointed architecture. And that's what we found. So over the years, lots of teams had built lots of layers in the architecture, and there was even duplication. So for example, validating if you were logged in on the mobile app and trying to log in via the web browser so that you would be logged out of the mobile app was a bit of functionality that existed in 2 or 2.5 layers in the existing architecture. So when we saw this, we decided we had to get back to the drawing board and think about purpose, because our cross-functional team did not want to be in a position where they had to release 7 different layers of an architecture and keep all of the dependencies in their heads. So with the simplest possible journey in mind, we defined 2 services. That's all that we needed at that point. And we defined their purpose. So we removed the complex channel logic because we were only serving the mobile app. And we said, well, we probably need a backend that is capable of dealing with bill payments, right? So let's just start with one. And because we're serving a mobile app, and bill payments as a backend shouldn't necessarily have to know anything about this mobile app, let's use the BFF or backend for front-end architectural pattern. And so the team ended up with 3 layers in the architecture. They had a user journey in the app, they had a BFF, and they had a backend. And when we showed this to architects in the business, we could point at them, read out the purpose, and they said, okay, yeah, I get what this is trying to do. Architects happy, team happy, and all they had to do was release 2 components. So the 5th principle, and it's also my favorite, I have to say, is we decided to take the upper hand in talking to legacy on our terms. So we were new, and our objective was to keep our code bases clean from legacy concepts like models, but also integration logic on how to find the right data in legacy. So a story appeared in our backlog to update the customer's balance after you had paid a bill. But that balance was cached somewhere on a farm, a web farm of 70 different servers with sticky sessions. So invalidating that cache was going to be really difficult for us. We did not know where it was, and we also did not necessarily want to find out. Obviously, the solution was to simply integrate with all those 70 databases directly, figure out where the data was, and then invalidate it. But had we done that, we would have been blocked both on gaining the knowledge in our team, as well as further down the line, having to make sure that this logic that we were building was still accurate and wasn't broken. We didn't want our code base to become tainted this quickly. So the trade-off was, do we ask for help with these dependencies of other teams, or do we fix it ourselves? And that really was the lens that we looked through, as I said at the beginning. Who is doing the work, and when are you doing the work? So in terms of who's doing the work, we got 2 patterns from domain-driven design, and I really encourage everyone to take a look at domain-driven design. There are a lot more interesting patterns in there. But the easiest ones that we could communicate about with our stakeholders was customer, supplier, and anti-corruption layer. And in their essence, there's a lot of theory to this, but in their essence, what they're saying is, if you put some abstraction layer between your legacy and your new system, the difference is whether you as a consumer are defining what that should look like, or whether the other team is providing you something. So in this picture, you can see that for this example of invalidating balances that were stored in a cache, we decided to be the customer of a supplier. We asked the other team, here's an API spec, can you build this for us? So that we just call you and you invalidate your cache. But there were other integrations where we said, well, we'll build a separate component, a little module in our code base that we could easily throw away when legacy would go away, that was taking care of the ugliness that was behind it, but provided a clean interface for our new code base to deal with. Now, there are more of these patterns, as I said, but we definitely found these the easiest ones to communicate with other teams, because the orange box that you see here is clearly saying, we are doing the work or you're doing the work. And then it becomes a matter of conversation, whether you are providing the other team with information on what you need, or if you leave it up to them to design the solution. And the last principle is to decentralize what is centralized, because you want to protect your team autonomy. So this came from a realization of how many bottlenecks there were going to be if we would have been blocked and dependent on every single dependency. So our objective was, again, in the light of shipping software to production quickly and building confidence with our stakeholders, that the team would be autonomous, would have control over what they were building, and could move quickly. So various journeys needed to display information from different parts of the system. And so aggregating all those APIs was going to be one of those things that we were solving with our backend for frontend. But obviously, teams were functionally decomposed. So there was a team who looked after, an infrastructure team that looked after the API gateway, and they were very keen to use all of the features that that product had to offer, including aggregating API calls, stitching schemas together, and so on. So again, we had a choice. Did we want to communicate with another team for every single change through a ticketing system and be the last one in the queue? Or did we want to remain autonomous and in control of how our software was working? And did we want to test everything by hand or once it had been deployed through the API gateway? Or did we want to test everything with unit tests and integration tests in our code base? Well, obviously we chose the latter. So the approach we followed, even though it seemed logical to put all of this in the API gateway, was to work with this team on a one-off basis. We provided them with all the information they needed. We asked them to configure a wildcard route that still gave them the level of control that they needed. But all of the endpoints after that wildcard would be handled by our BFF that we had built. And so the team set this up and was in control of the deployments after that, managing all of the version compatibility of the mobile app after that. And the best of all, we didn't have to shoot more tickets into a system waiting for another team to make changes. So our development team was happy, and the infrastructure team was happy. So what did we learn? Well, legacy is given, and we shouldn't think that we can escape it. The gravitational pull is really strong, and having rigor and discipline in the approach are the best characteristics you can have. But in addition, these six principles may be helpful. So we said, well, design with how you want to work, rather than designing things for the best, being the best. Care about not caring, ruthlessly ignore what you don't need. Decide to defer. Is this the right time to make the decision? Is this the last responsible moment? In your architecture, define purpose over the components that you build, rather than the function that they fulfill in their lifetime. Integrate with legacy on your terms. That's the way that you can keep your code clean, and collaborate with other teams that may actually benefit others. And on the topic of benefiting others, decentralize what is centralized so that you can remain autonomous, and maybe reuse falls out of that. So across all these themes that you can see that we looked at architecture through a bit of a different lens. Team autonomy was the top priority for us. And by following the normal agile methodology of delivering iteratively and incrementally this software into production, we were able to build the confidence with the stakeholders and demonstrate that modernization of a small, thin slice of a customer journey was actually possible. Thank you very much.